Welcome to qnawire.
Okay, so this is the force diagram for the car. So let's assume that the car is tipping at point A. And this will give us the moment at point A can be equal to W sine theta T times 2.5 feet plus NB times 5 feet minus W cosine theta T times 2.5 feet is equal to 0. W here is the gravity of the car. Theta T here is the tipping angle we're looking for to determine. And NB here is the normal force at point B. If we do some arrangement here, we have sine theta T minus cosine theta T is equal to negative NB times 5 feet over W times 2.5 feet. Since we assume that the car is tipping at point A, therefore the normal force at point B should be equal to 0. Because when the car is tipping at point A, that means the side of the car at point B is completely off the ground. Therefore, the normal force at point B should be equal to 0. And this will give us sine theta T minus cosine theta T is equal to 0. So I have sine theta T is equal to cosine theta T, which means that angle theta T here is equal to 45 degrees. So the tipping angle is equal to 45 degrees. So now let's apply the force equilibrium to this question. So since we consider the x direction is pointing along the inclined surface and the y direction is perpendicular to the surface, therefore the net force at the x direction can be equal to Fa plus Fb minus W sine theta is equal to 0. And Fa here is the friction at point A, Fb here is the friction at point B. This will give us W sine theta is equal to Fa plus Fb. And the net force along the y direction is also equal to 0 since it's in equilibrium. Therefore, I have Na plus Nb minus W cosine theta is equal to 0. So W cosine theta can be equal to Na plus Nb. Remember, the static friction at point A can be equal to mu s Na, and the static friction at point B can be equal to mu s Nb. Mu s here is the coefficient of static friction. Therefore, I have Fa plus Fb is equal to mu s times Na plus Nb. So we have W sine theta over W sine theta over W cosine theta can be equal to Fa plus Fb over Na plus Nb, which is equal to mu s times Na plus Nb over Na plus Nb. As you can tell, Na plus Nb can be cancelled out, and this will give us W sine theta over W cosine theta is equal to mu s. And remember, W here can be cancelled out as well, and sine theta over cosine theta is equal to tangent theta. Therefore, we have tangent theta is equal to mu s. So angle theta, which is the greatest slope angle we're looking for to determine, can be equal to inverse tangent mu s, which is equal to inverse tangent 0.4, and this is equal to 21.8 degrees. So as you can tell, the theta here is less than the tipping angle. Therefore, this is the greatest slope angle the shoulder can have without causing the car to slip or tip over. So let me write down theta is the greatest. And these are the answer for this question.